Hi everyone, let's continue with example 6 from solving applications involving right triangles. Okay, so this time we have a flagpole on top of a building. So let's say we have, here's our ground level, and here's our building, and here's our flagpole. Okay. And we know that the angle of elevation from a point on level ground 330 feet from the building. Okay, so if we go out 330 feet, the angle to the top of the flagpole is 63 degrees. So if we look at the top of the flagpole from ground level, we get an angle of elevation of 63 degrees. We also know that if we look at the bottom of the flagpole, assuming this is somewhere where I can see the bottom of the flagpole, the angle changes slightly. It's now 61 degrees. So a really good piece of vocab I can sneak in here, it'll come up in other things as well, is this is telling me that the angle subtended by the flag is 2 degrees. So that's the angle subtended. So if you ever see that wording, angle subtended, that means if you draw a line to the top of the object and then draw a line to the bottom of the object, or if it's not a top and bottom, both sides, the angle between those two lines is the angle subtended by the object. Okay, but that's not what we're looking for here. So end of sidetrack. We're looking for the height of the flagpole. Height. Okay. So here's the problem with that angle that I pointed out, the 2 degrees. You can even read that in there. That's great. And H is definitely a side of this little skinny triangle containing the 2 degrees, but we run into a lot of trouble when we recognize that this little skinny triangle is not a right triangle, so none of our right triangle trig applies. That'll be the last thing we work on in this class is non-right triangles. We can, however, focus on a couple of right triangles that we do have. Let me snag a color. So for one thing, I have the big right triangle right here. And I know that its base is 330, and I know this interior angle is 63 degrees. So I could use that to find the total height of the building plus the flagpole. So we'll call that big H. So I'm going to say from 63 degrees, I want opposite, I have adjacent, I'm going to use a tangent. Tangent of 63 degrees is equal to H over 330, which means that our H is going to equal 330 times tangent of 63 degrees. And we can ask the calculator for that one. 330 tangent 63 degrees is approximately 647.66 feet. Okay, so that's the height of all of this stuff. That doesn't quite help me get the height of the flagpole, but it's a step in the right direction. So now, if we focus on the other good right triangle we have, it's this one, the one that only includes the building. So here's my smaller right triangle, and it contains a 61-degree angle, and I can use that to find the height of the building. So we'll call that B. Okay, so the height of the building, let's see, I'm going to do the exact same thing. Tangent of 61 degrees is equal to B over 330, which means B is equal to 330 times tangent of 61 degrees. We can just snag that last entry, change that to a 1. So the total height of the building is roughly 595.34 feet. What we want to know is the height of the flagpole, and that's going to be, so little h is going to be big H minus B. So if we take that big H and we subtract off B, we get about 52.33 feet. Fairly tall. All right, thanks for watching.